Hello class. In this video we're going to be reviewing how to find scale factor. Now before we go into any examples, we'll need to make sure that we all understand what scale factor is. And all scale factor is, it's a value that determines how much a shape shrinks or grows. Now if you remember from class, we know that two figures are similar if they have the same shape and if they have the same scale factor. Now, an important thing to remember is you want to make sure that you have the correct corresponding sides. Now, in this case, it's pretty easy because both sides are facing the same direction, so I'm just going to highlight these in red. I know that 8 is going to correspond with 4, since these are the shorter sides of the rectangle, and that's also true of 12 and 6 corresponding, since these are the long side of our rectangle. Now, in most examples, you're going to already be told that these sides are similar, or that these shapes are similar, so you don't have to test every single side in order to make sure that it's the same scale factor. Now, in this example, we can see pretty quickly that if I want to go from my figure from small to big, all I have to do is multiply by a factor of 2. Now I do want to remind you that scale factor is always determined by multiplication or division, so don't be tempted to use addition or subtraction as your scale factor. And again, I can tell these are similar because 6 times 2 is going to give me 12. So I know my scale factor from small to big is going to be a factor of 2. Now if I want to go backwards and go from big to small, all I have to do is use the reciprocal of 2. Now, as you know, 2 is equivalent to 2 over 1, and if I want to save myself a little bit of time, what I can do is just take the reciprocal of 2 over 1 and just say 8 times 1 over 2 is going to give me 4. Same thing with 12. 12 times 1/2 is going to give me 6. So I know my scale factor from big to small is 1/2. Now, another quick way to be sure that your scale factors are correct is if you're going from big to small and your shape's getting smaller, your scale factor has to be less than 1, which is why we have a just normal fraction here. Any scale factor going from small to big is telling you that our scale factor is greater than 1. Now, in our next example, we're going to see that we don't always have such nice numbers to deal with. I can see that 6 corresponds with 9, since these are both the shorter side of the triangle, and that 12 corresponds with 8. Now, it doesn't matter which direction I go, or if I go from big to small first, or small to big. In this example, I'm just going to be going from small to big. Now, multiplying 6 by a value to get 9 is kind of tricky, and you might not always see what it is. In most cases in the real world, scale factors are fractions, they are decimals, they're not always nice numbers. And in this example, there is a nice easy way to figure out what our scale factor is. Now, I know I have to multiply 6 by a value to get 9. So in this example, I'm going to be writing a quick equation because I know 6 times our scale factor is going to give us 9. Now, this is called the isolation method, and what it means is we're trying to get the scale factor, this variable s, all by itself so that we can determine what it's equivalent to. Now, here you can see that we're using multiplication, and in order to get rid of that, what we'll be using is division. So 6 divided by 6 is going to cancel out, and whatever I do to one side of my equation, I have to do to the other. So I have 9 over 6 as my scale factor. Now, as I said, as I may have mentioned or may not have mentioned, 9 over 6 is our scale factor, but I want to reduce this to the simplest form fraction. So I'm going to be looking at 9 and 6 and trying to find a common factor, and I should be able to see that I can divide both 9 and 6 by 3. So 9 divided by 3 is going to give me a value of 3, and 6 divided by 3 is going to give me a value of 2. And because I was going from my small shape to my large shape, I do know that I'm multiplying by a factor of 3/2. Now I do see some students who are tempted to turn this into a mixed number, which is fine. But I do want to remind you, if you want to find your scale factor going the other direction, that it's only the reciprocal. And in this case, instead of having 3/2, my scale factor going from 9 to 6 is just 2/3. So again, from big to small, we have a scale factor of 2/3. And our original scale factor that we found from small to big is going to be 3/2. Again, the scale factor is less than 1, and this scale factor, this improper fraction, is larger than 1. Now, I did mention that you do want to be careful of your corresponding sides, and you'll see why in this example. Now, 21 and 11, a lot of people would be tempted, especially on the test, to say that these correspond since they're in the same exact spot. But you want to compare the short side to the short side and our long side to our long side. Now, in this example, I can see that I can multiply 7 by 3 to get 21 and 11 by 3 to get 33. Now, just to show you another example of the isolation method, I'm going to pretend like I don't know that. So I'm going to be figuring out that 7 times my scale factor is going to give me 21. So I know 7 times my scale factor is 21. And just like last time, we're going to be using the opposite operation for multiplication, which is in this case is division. My scale factor is 21 over 7, but I know 21 divided by 7 is just 3. And as we mentioned before, if I go the opposite direction from big to small, instead of multiplying by 3, I'm going to have a scale factor of 1/3, since that's just the reciprocal of 3. So you'll see again that from big to small, our scale factor is 1/3. It's a value less than 1. And from small to big, it's times 3, a value that's greater than 1.